So you have seen that during the sample prep workflow, there are several bottlenecks and there are different solutions to address them. All these solutions will contribute to the speed of the lab, to the speed of the analysis, to the quality, to the efficiency of the workflow, and also will reduce these disruptions. I would like to thank you for the attention and I wish you will enjoy the rest of the e-symposium. Thank you and all the best.
Thank you for that fantastic presentation, Giulio. Up next, we have Stephen Markle. Stephen is the Product and Application Manager for Milestone, overseeing marketing, research, and customer needs across Milestone's equipment lines in the US. Prior to Milestone, he has worked as a chemist in a cannabis testing lab, and most recently was the VP of Production for Planet 13, designing and managing an 18,000 square foot cannabis production facility and formulating over 40 edible SKUs. He obtained his bachelor's degree from New Mexico State University. Thank you for joining us, Stephen. Please get us started.
Hey everyone, and thank you again for joining our workshop today on Total Workflow Approach to Sample Preparation. My name is Stephen Markle, and I'm the Products and Applications Manager here at Milestone Incorporated in North America. And I'm coming to you from our demo lab based out of Shelton, Connecticut. Before we start jumping into some workflow solutions, I want to talk about just real quick what is trace analysis, broadly defined as measurements below 1 part per million. But I always think we lose touch on how cool some of the work we all do every day is. So just to put it in a little bit of perspective, 1 ppm is equivalent to finding your first gray hair. 1 ppb is equivalent to finding a needle in a haystack. And 1 ppt, which some of you guys work in every single day, is a contact lens on a 100-mile beach, the equivalency of finding a contact lens on a 100-mile beach. So it's really neat work, and a lot of things can go awry with it. Let's talk about those. Obviously, the lower concentration, the less reproducibility we're going to get on our sample. You get what's called a Horwitz trumpet right there. So the lower we go, the more problems. That can be due to matrix effects within the sample, losses throughout your procedure, cross-contamination between other samples in your environment, noise within the machine, interferences within your sample matrix, and multi-step procedures within your laboratory. So we'll talk about how to address some of those problems in the following couple of slides. Our main goal during sample preparation is to ensure high quality analytical results, right? That's why we start with our initial step and move forward to an ICP. To get high quality analytical results, you need a couple of these pillars here. You need a homogeneous sample, so you have to make sure that whatever you're testing for and whatever your elements of interest are come from a representative sample batch. It can be one individual fish oil out of a batch of 100. It could be thousands of capsules ground up into a large vat of powder from a batch of 1 million, right? That's up to your own internal quality control policies and such. But we need to get a representative sample out of what we're looking for. So we'll touch on how to do that. Labor cleanliness to get clean blanks is extraordinarily important. So all of your sample prep components need to be contamination free and clean of any background. Reagent purity, we'll touch on highly with the use of our DuoPure as well to get you highly pure reagents at a fraction of the cost and through your own supply chain. But we'll touch on how to also keep them pure just through good laboratory practices. Sample prep technique we'll touch on a bit, and then the analytical technique we'll leave for some of the other presenters to touch on. So sample selection and preparation, you have your sample mass, and it's going to influence a lot of things. It influences how to get a homogeneous sample, like I touched on a previous slide. It could be one fish oil out of a batch of 100. That's easy. You just take that single fish oil. You might not necessarily need to homogenize a bunch of them together if the batch is small enough. But depending on the type of sample and the type of work you guys are doing, you're going to need to have a homogeneous sample, whether it be ground up cannabis flower or an aliquot of wheat from a large field. This can be accomplished by a bunch of different means. I like to use coffee as an example because we all do this every day, most of us. You accomplish it by grinding. You grind your coffee beans down, you increase their surface area, you get a representative sample, and then you perform essentially an extraction. But there's a bunch of different ways to do that. You just want to make sure you have a homogeneous sample set. The amount of sample mass that you digest in your sample preparation is going to influence the detection limits of your equipment. So the more sample mass you have, the lower detection limits you're able to achieve because you can do less acid dilution and inject more concentration into your ICP system. And it's going to have a large influence on the reactivity and the pressure within your digestion vessels or vials, depending on the methodology you're going to use. The amount of sample that you have to use may be mandated by your internal quality control policy, official methods under your industry, or regulatory bodies such as the EPA or FDA. But that chart on the right side there shows you that the pressure is going to increase based on the amount of sample input into the microwave. So at no sample with just blank acids, you are going to generate some pressure, but it's below 10 bar. At 0.1 grams of sample, we get almost a 20 bar. And you can see as we increase the mass, we get a larger exothermic reaction at the beginning of the run, and the pressure continually increases throughout the run. So based on the limitations of your equipment, you may also be limited by the size of sample mass that you're able to homogenize and prepare. While you're weighing out those homogenized samples, airborne particulates are carried throughout the lab, and they're always present as dust. Daily operation and airborne currents are going to cause particulates to move around. And ion transfer is another issue when you're doing sample preparations. For instance, opening a bottle, PTFE bottle, induces a negative charge in the environment around it and draws in all of the positive particulates that are surrounding it. So you can get stuck on the neck of the bottle or your digestion vessel inside of the cap, and that can cause cross-contamination. To mitigate that, you can use some of these tools that I have here on the right. There's a small Zerostat handheld ion gun that you kind of pull the trigger on, and it will neutralize the area around the scale. And then some labs doing trace work are able to have this small ion fan. It's a very gentle air current that continuously blows positive and negative ions across the balance to remove any interferences and reduce any static charge. Again, touching on cleanliness, humans are the main point of contamination in most labs, mainly because we generate the particulates that are in the environmental contaminations. So a couple of interesting examples. If you're sitting without moving like I am right now, I'm generating about 100,000 particles per minute. But if I get up and run up some stairs, I'm going to generate over 100 million particles per minute. So depending on the type of lab environment, how many people you have moving through, it can become a significant issue. And then a couple of activities that you can do in a lab, such as rubbing a painted surface or writing with a ballpoint pen, everything you do can cause cross-contamination. This is obviously only important if you're doing highly trace-grade work, but the practices involved in keeping a clean environment are good across all types of analytical work. There's also more human influence. Some of those particulates that come from us can be like human hair, which has a lot of magnesium, cadmium, lead, and a couple of other heavy metals inside of it, as well as zinc. Human sweat is another big one. So you have concentrations, again, high in zinc, iron, copper, and a ton of salt, or sodium, I should say. And then if you're wearing makeup, things like lipstick, blush, powder, mascara have a ton of elements present. And a lot of those may be of interest in your analytical work. So any eyeshadow that might have fallen off or any nail polish that might chip could cause cross-contamination issues within your lab. So all of these things are just important subsets to keep in mind when you're working in sample preparation. There's obviously preventative measures that you can do to help mitigate this, but I always want to point out that even clean room environments can't fully mitigate the problem. On that slide right there to the right, you can see an ordinary lab has, let's say, iron at about 200 nanograms per meters cubed, when a clean hood would have it at 0.9, and a clean room in this scenario was almost the same as a clean hood. Same with the copper and the lead, they can't get it all the way out. So there's always going to be some contamination. Our job is to just try to minimize it as much as possible. So mainly, of course, when you're doing any lab work, it's fundamental to utilize nitrile gloves that are impervious to skin oils and sweat. And you want them to be powder-free. All that powder has elemental contamination that can cross-contaminate across your sample matrix. And your gloves are only as clean as the last item you touched. You want to change them routinely, right? In between samples sometimes, depending on what kind of work you're doing and if you have to actually physically touch the sample itself. One of my old bosses used to say, we don't charge you for gloves, just change them as much as you need to. So I always drive that home whenever I'm managing lab staff. You want to avoid cotton or linen lab coats. That's mainly because those types of materials can give off lint, which can also have elemental cross-contamination that can mess up your blanks and your results. So you want to utilize lint-free materials such as nylon, polyester, Tyvek garments whenever possible if you're doing that trace grade work. Jumping into reagent purity, the container selection of the reagent is important. Prolonged storage of these solutions prior to you doing your actual trace analysis is not recommended, but different materials will just carry different levels of contamination. Down here is an example elements of interest on the left side, and then moving across, we have borosilicate glass and then different grades of quartz material. You can see that across the top on aluminum, it was a major contaminant in borosilicate glass. Quartz type 1, we were at 74. Type 2 was at 68. And then type 3, the cleanest type of quartz, was at less than 0.25. And that's in micrograms per gram. But even just putting something in a glass container versus a quartz container can cause enough elemental contamination to either mess up your blanks or create something of a false positive on your analytical results for whatever you're looking for in your work. So how do we control it when it comes to the other than container type selection? And just to touch on that again, we touched on glass versus quartz. Down here is a bunch of different synthetic polymers, low density polyethylene, high density polyethylene, all the way down to PTFE. Again, similar elements of interest as the previous slide, but you can see as you move down to PTFE, FEP, and PFA, the rest become pretty much non-detect, and you have very, very low levels of contamination of some of the more common elements that we just find around us in our environment. So to not transfer any of those contaminants over, what we want to do is limit the surface area to volume ratio as much as possible on the container. So as little acid or reagent is touching the walls as it can, so it's less likely to leach out. You want as much within itself as possible. The time of contact between the solution and the surface needs to be as short as possible. So obviously you can't limit the time in contact from the stock bottle that it came on. So you want to leave it in there as long as possible. But if you know that you're going to be transferring it out, back and forth, you want to make sure that you're going to transfer it and then use it as soon as possible. That way it has less contact time against the walls of those containers to leach out any possible contaminants and cause issues on your blank results or your analysis themselves. When you're going to use containers frequently, or really as they show up into your lab, if you're doing elemental work with them, you do want to precondition them with acid leaching, ideally with acid vapors, which I'll touch on when I come back in the talking about our last piece of equipment and the last techniques at the end of the presentation. But an acid soak will do not the same thing as well. So what you can do is just set those containers in a 5-10% acid solution and obviously an acid-proof bath under your fume hood. Let them sit overnight, and that acid will leach out the majority of the contaminants from them. You remove those bottles, give them a DI rinse, possibly another acid soak afterwards in a clean acid solution. And then after that, you'll have them nice and clean, ready for your elemental analysis. One of the main workflow solutions we're going to talk about involving Milestone equipment in a minute is that we only want to open bottles when necessary. We want to eliminate multiple transfers from the same bottle as much as possible. Every time you open that bottle, there's a chance for cross-contamination to enter it. And just to show what that looks like, this is the analysis of some ultra pure water over 8 hours. So it was opened, analyzed initially, and you could see that the total contaminants of the top 10 were about 74 nanograms per liter. After 8 hours, that same bottle was tested again, and the contaminants range from 368 all the way up to over 2,600 nanograms per liter. Obviously, high up in the calcium, potassium, sodium, et cetera, the ones that are very common, but you can see just by leaving it open in a standard lab environment, you can have a massive increase in cross-contamination. So if we want to utilize cheap acid and get it clean, or if we want to mitigate possible contamination in an acid supply, there's a couple of ways we can do it. Traditionally, reagent purity has been achieved by using distillation, but distillation and really any technique, there's no single purification method that can remove every single contaminant. So what we're trying to do is get them as low as possible. So previously and still currently, distillation is used. There's an old copper still to the left side and a more modern short path distillation unit on the right, can be used for the same purposes. But they're used to bring it up to a boiling point, recondense, and purify it to improve quality. Has a lot of drawbacks that we'll touch on. And to get into that, I'll go into the Milestone DuoPure and how it can be a solution for this issue. And we're going to go through our first kind of workflow comparison and talk about our ultra pure acid supply chain. So in touching on some of those drawbacks on traditional distillation, again, it's been used for over a century to improve the quality of liquids. Much of the spirits that we drink today are done by distillation still. The main drawback is, in this scenario, it generates steam droplets and bubbles. The heat is coming down from a traditional hot plate or an open flame, some other type of heat source, and using convection to carry through up to the boiling point of what we're looking for. But there are still some droplets and aerosolized particles that come out of the what we call mother liquor. Those particles can carry contamination, in our case, elemental contamination, up into the distillate and transfer it. So it can cause issues. It just doesn't make as pure of a product. What we've done at Milestone is we've condensed subboiling distillation, which is the same technique that commercial suppliers use, and down into a benchtop model. So it uses infrared heating to gently vaporize the surface of the liquid only. And since it's so gentle and only coming from the surface, it prevents the formation of those aerosolized particles that don't, and so it doesn't carry the elemental contamination with it. All of the contamination remains behind in the mother liquor. Principles of operation can be seen on the picture on the right side of the slide there. We have an infrared heating coil, again, going to heat the surface of the liquid, use that to vaporize off the particles, which will recondense on a cold finger powered by a chiller or tap water. Will condense down and drip off into a PFA collection bottle where our pure acid will remain until we take it out of the system, which I'll show you later in the workflow. A quick comparison in micrograms per liter, there's sub-boiled distilled versus traditional distillation. You can see with sub-boiled distillation, the technique we're going to be talking about today, our total contamination was 2.3 micrograms per liter. When in traditional distillation, it was 220 micrograms per liter. So not an insignificant amount of contamination. Why do we want to use the DuoPure? One reason is we gain control of our acid supply. So you can make it on demand and have fresh, high purity acid like we talked about earlier. You don't want to have reagents sitting around a long time. You don't want to have to open and close them frequently. So if you can make fresh, clean, ultra pure acid on hand, you can have it fresh for the day or fresh for the week, whatever your lab wants to utilize it as. But you can have it when you need it, and you can make it fresh when you need it as well. We saw also an increase during all of the supply chain issues during the pandemic. It was always easy to get reagent grade acid and purify it yourself. It became cumbersome to get ultra trace acid. So we saw an increase in people using this not only for the ROI benefits of the system, but also to control their own acid supply in-house. They just got a bunch of stock reagent grade acid and they were able to purify it as they needed it for their work. The system is very automatic and safe. It is a set it and forget it type instrument. You simply have to load the acid in, which I'll show you how to do during the workflow. Press play. When the timer comes back, you come over, take the bottle off, and you have your ultra pure acid ready to go. It's a very fast system. It has high productivity. With the 2 stills going at max power, you can get up to 400 mils per hour of purified acid. It uses high purity quartz stills, so we have no porosity or memory effect. It gets cleaner over time, so it mitigates any cross-contamination that way. And one of the major benefits here is that it will provide a 90% cost savings to your acid, which we'll touch on later through an ROI calculator, a fraction of a cost compared to what you would buy from a commercial vendor. To talk about the speed and throughput, the distillation power that you program into the system determines the quality and also the throughput speed of the acid that's being produced. A good rule of thumb, the faster the distillation, the less purity, right? The slower you go, the lower the boiling point, the more pure that is going to come off of. The DuoPure is not controlled by a temperature setting. It's just controlled by percent power that's given to the infrared coils. So here you can see on the table there, it can do water, nitric acid, and hydrochloric acid. With the 2 stills side by side, you could run them in tandem. You could run both for nitric. You could run one for hydrochloric, one for nitric, or one for water, one for nitric, any combination of those 3. But you can see at a 20% power with nitric acid, we're getting 15 mils per still, but at a very high purity. At 60%, we're getting 80 mils per still, but at a less high purity. So it's to your lab's needs. To touch on the quality of the acid that we're making, this is done with, this was a distillation of nitric acid, 65% reagent grade from Sigma Aldrich. This was at 45% power and a single distillation. You can do a double distillation, which we'll touch on in the next slide. This led to a distillation rate, that type of acid with that level of power led to a distillation rate of 45 mils per hour per still. So again, if you have a system with 2 stills, you could double that throughput, increase your speed. This was produced in a Milestone lab and was analyzed at the National Cancer Research Lab with an ICP-MS. And just to be clear, they are not equipped with a clean room. They're obviously a very clean facility. However, as we touched on previously, even a clean room is not fully free of environmental contamination. So after that single distillation run, you can see the data on the right. Magnesium, obviously a very common elemental contaminant around the air, as well as calcium. You still see some of that, a little bit of iron. Most of our elements of interest in this case were non-detect, and some of them were very, very low ppb. If that is not low enough for the type of work your lab does, you can take that acid and you can do a double distillation and repurify it once more through the DuoPure again. And that can yield to a similar equivalent quality to a Baker Ultra X2 high purity grade nitric acid. You can see all our elements of interest here, and you get down to the PPT level across the board. very efficiently and quickly. To touch on the ROI aspects of the system, obviously every lab is different. They're going to have different costs per acid. They're going to go through a different amount of liters on a per month basis. But just as a good rule of thumb for this one, we took nitric acid. We used JT Baker Ultra X2 as the grade, and hydrochloric acid as well. The cost roughly was about $1,100 per bottle between those two acids, and that's per liter. The equivalent of reagent grade is about 10% of that cost, $160, $150 per bottle, depending on the acid. Again, this is going to depend on the supplier and the agreements you guys have with them as well. But overall, a good starting point. We're going to take a lab and we're going to assume that they're going through 5 liters per month and that their cost per liter, as seen above, is about $1,100. So their total cost of acid per month is just north of $5,500. If they replace that ultra pure acid with the equivalency of reagent grade acid, again, 5 liters at $160 per bottle, is a total monthly cost of only $800. So their savings could be north of $4,500, total of $4,775. If the average cost of the Duopure with 2 stills is $22,000 and they're saving that per month, the system will pay for itself in 4.6 months. So the ROI is very high, the acid quality is very high, and the system is quite efficient. So if it makes sense for your operation and you're going through a lot of ultra trace acids, this is a great way to bring that process in-house, save money, get pure acids on demand to mitigate that cross-contamination we talked about earlier, and really increase the throughput and efficiency of your lab from a workflow standpoint. Obviously, this number is going to be different for any lab, but if you were going through 10 liters a month, the system would pay for itself in 2 months. If you were only going through 2.5 or 2.5, it would pay for itself in about 8 months. So, but these are just great ballpark figures to use when you're trying to decide if bringing in-house acid purification is right for your laboratory. So again, you can distill your own ultra high purity acids from reagent grade, leading up to a 90% cost savings versus buying it through a commercial supplier. System has a simple user interface. Again, set it and forget it. It has its own timer. You can run it overnight, and that stores the methods for all your future use. You get to purify what you need when you need it, eliminating a lot of those issues that we talked about earlier in the presentation. You get to gain control of your acid supply. May or may not be an issue for your lab currently, but it's always great to have it in your back pocket. It easily integrates into your workflow, which I'll show you again later. And it uses a high purity quartz still, so there's no porosity or memory effects. Those stills just get cleaner over time. Once we have our acid and we have our samples weighed out, there is one more solution that we have to talk about, and that is until we lead into some more workflow, and that is going to be Milestone's automated dosing solution known as the EZ-fill. So we're moving on to from ultra high purity acid to our reagent and sample handling. After that, I'll hand it off to some of my colleagues to talk about vessel handling and some of the other techniques and workflow improvements we're going to show you today. So continuing on into reagent handling, let's talk about some reagent addition steps today. It is one of the most tedious and unpleasant steps in a laboratory, and it requires a significant amount of labor time, and which incurs a significant amount of cost for any type of lab work. It's still done manually with a lot of drawbacks. The operator is exposed to acid vapors. Even in a fume hood, there is still exposure to vapors. It's a time-consuming process. The operator could be doing other work while this step is being automated. It's prone to human error. The operator could have their pipette set wrong or their bottle top dispenser set wrong. Hopefully they're not pipetting by hand like that photo there, but I've seen some labs do it. And there's a high risk of contamination. You're open to environmental factors. There's a fume hood pulling in air around. They might forget to change a pipette tip. There might be contamination in that bottle top acid dispenser. There's a lot of different factors that can come into play, and there also could very well, like we touched on, be contamination from the human element involved in this process. So to help with these issues, Milestone is going to improve your digestion workflow by introducing the EZ-fill. So this is an automatic dosing station that basically does all of the reagent addition for your operation. There's a hands-off approach, so the operator no longer has to handle acid except for the initial transfer into the machine, so it avoids their exposure to acid fumes. There's a high-quality, high-precision peristaltic pump on the side of the instrument with high-purity PTFE tubing that provides consistent results across reliable dosing ranges and avoids any risk of cross-contamination. There's a high flexibility. It's compatible with a variety of vials and vessels that I'll touch on later. And because all of the acid contact components are high purity PTFE, it's compatible with all reagents, including hydrofluoric acid. So huge safety aspect there to be able to remove any operator having to handle that aggressive of an acid and being able to unload it into an automated machine. The software is a touchscreen terminal. On a Microsoft Go, it's very intuitive and easy to use with preloaded methods. We'll touch on that later again. And overall, the system's going to improve your workflow, decrease your labor, and allow for a higher productivity environment. The dosing compartment is made of anti-corrosive polypropylene. The door is has a magnetic safety interlock, so it can't be opened while it's running. And as that compartment's closed, there's an air inlet filter on the side that has a dedicated filter, so it is pulling the acid fumes out through an exhaust that would be wired into your fume hood or house exhaust system, but it's going to capture any particulate contamination. That filter just needs to be cleaned out periodically. While all that's happening, the operator can go hands off and go do something else. There's an LED light on the front too that will turn from blue to white when the run is finished, allowing the operator, if they're across the lab doing other work, to quickly notify themselves that the machine is done and they can go take their samples out, cap them, and move on to their acid digestion. It's a highly capable machine. You're able to utilize up to 6 reagents at a time. Again, due to the high purity PTFE acid contact components, you have full reagent compatibility, including hydrofluoric acid. The line will automatically flush when changing acid, so you don't have to worry about any cross-contamination or incorrect acid dosing volumes. The waste from that flush is collected through a dedicated drain and into a carboy for easy disposal. And both the reagents on top, all 6 of them, as well as the waste amount in the carboy, is tracked real time in the software. So the system will automatically notify you if you need to top off a bottle on the top, or if you need to empty your carboy before you start your run if it's already almost full. So it's going to minimize any disruptions in your lab through that level of automation. The operator simply has to tell it how much reagent it added back into the bottle, so it keeps an accurate count. Again, the system comes pre-programmed with the vessel configurations you see on the side there, but it is compatible with most digestion vessels from other manufacturers, as well as auto-sampler vials that are used for your ICP. Today, we're going to use it on a Milestone UltraWave 320 rack and a Milestone Maxi 24 rotor-based digestion vessel rack. The software, again, is very fast and intuitive to learn. You can quickly pull up preloaded methods. So if you're doing, say, multiple EPA methods throughout the day, it's not something you have to re-enter each time. You can just quickly recall the saved methods through the Windows-based software, and it will allow you to pull it up, hit play, and the system will do the rest for you. It is a Microsoft Surface Go that is connected to the system by Bluetooth or a USB-C cord. And like I touched on, it allows for customized methods for all your routine processes, fully customized across all 6 reagents that you have on top through different amounts. The system can go down to a mil of accuracy and dispenses at 1.5 mils a minute. So the EasyFill is going to allow your operation to have an enhanced safety. Again, we're removing acid contact from the operator, and we're avoiding acid exposure to them. It makes their work-life environment much more efficient and easy to be in. We're going to improve the workflow process by automating reagent addition. So we're going to take that labor away from the operator. They're going to be able to do something else while the machine does all of the tedious work for them. They can use their hands for more important work to get done. And again, the ability to use pre-saved methods is going to allow them quickly recall whatever method they need to run, press play, and go back to their more important work. The system's highly reliable. There's very few moving parts. There's limited risk of contamination because of the airflow and the safety interlocks. It eliminates that human error that you might see in traditional reagent addition. And that precise peristaltic pump is going to allow for a very robust system with accurate dosing. Because of the high purity PTFE components, it's suitable for, again, all reagents for a very efficient process. You can do reagent addition. You can also do pre-dilution. So if you have a set amount coming out of your digestion vessels, you can pre-dilute up to that set amount, ready, and then be ready for your addition into your ICP. And like we touched on, compatible with all current Milestone rotors and racks, but also many other types of vessels and equipment that are manufactured by other vendors as well. And with that, I'm gonna go put on some gloves so I don't do any cross-contamination, come back and show you guys our EasyFill and our DuoPure system and how you would use them in a traditional workflow throughout your laboratory. All right, so we're here at the DuoPure, which just finished a run. And I've got my safety shield open just so I can show you guys the internals of the system here. This is the bottle that I'm going to put my reagent grade acid in. It is the only time that an operator is going to have to maneuver acid to the system by hand. They would take this out, fill it in a fume hood with their reagent grade acid, bring it over here, put the cap on, and then the system is ready to begin running. There's a single head diaphragm pump in here, and this is a buffer bottle to avoid getting any acid vapors into this diaphragm pump so it lasts longer. I'm going to hook up this hose into the pump footing here. If I wanted to add more acid, and I'd come over to my terminal and hit the pump button. You would hear it pump, and it's going to begin taking acid from my reagent bottle through the top of the line here, down this neck, and it's going to fill my reservoir from the bottom up. After that's done, I'd come over to my software and I'd press play, and these infrared heating rods here would begin vaporizing the acid off the surface. It would come up as a vapor and hit the cold finger here, which is powered by a chiller that you don't see on screen coming through the side. That vapor is going to hit the cold finger, recondense down onto the small pick at the end, and drip down through this tube into our ultra pure reagent grade or ultra pure acid bottle here. So since my run is done, I have pure acid here. I have not opened this bottle. This is closed to the atmosphere, so it's a closed system. Everything's very clean. Again, the quartz gets cleaner over time because there's no memory or porosity on this. And that's pretty much it. So this run is done. So the way I'm going to take it off is I'm going to hold the TFM component here. I'm going to take the PFA bottle and gently turn it and unthread it. Once you get the threads to release, there's a small spring in here that will allow you to push the bottle down, slide the cup over, and take out your high purity acid. Now, I've opened this acid bottle one time. It's been exposed to atmosphere for a very minimal amount of time. And I'm going to take it directly over to my EZ-fill automated dosing station. I'm going to take my Fritz and remove it from the plastic bag I had it in to keep it clean. Place it into the system. Thread my bottle top on. Come over to the software and press play. It's going to activate this XYZ arm. And currently it's doing a rinse of the first acid that I'm running through it, which is nitric. It's going to rinse 20 mils of nitric acid, and that's a customizable feature. You can put as many mils as you want to rinse. It's going to rinse that out through the drain, which is going down, and I have my carboy stored under the cabinet here. It's done with that initial rinse, and you're going to see that arm come around and begin to fill our vials on our UltraWave 3 20-position rack. I've got a mixed variety of samples on this rack here, including polymers, oils, personal care products. My colleague John Paul is going to get into the specifics of how this system will work and during his presentation, but it does have mixed batch capability, so I can do pretty much anything I want to, all in this one rack type here, any type of sample matrice, I should say. The masses and such are going to be dependent, and the acid chemistry is going to be dependent on the type of sample. Again, you up to 6 reagents on top of the system. The peristaltic pump's running on the side now. It's just simply going through and filling each individual vial with the set amount of acid that I told it to. And in this case, it is pumping 5 mils of acid per vial. So while this is going on, I could go to my ICP. I could program in my run. I could fire up my torch. I could start running calibration standards. And then once I'm all done with that, I can come back over here and collect my samples, cap them, and bring them over to my microwave digester. The exhaust fan is going, the door is closed, so there is no particulates making it in there. They're getting caught on the filter. And right now I'm not being exposed to any acid vapors. So the light turns white, the system is finished. I can open up my door. The system will no longer allow itself to run. I can pull out my vials with 20 positions, and I'm going to take these over to my colleague, John-Paul, and he's going to show you them on the UltraWave 3 later on in the presentation. I also need to prepare some ground hemp samples for my colleague Eric to talk about the ethos system and best practices in rotor-based digestion. So for that, I'm going to take out the platform that I had set up for the UltraWave 3. I'm going to take my 24 position rotor set here, place it into the vials. The EZ-fill is able to handle 2 of these for a total of 48 vessels. Now that I have these in, I close the door, come over to my software, load up my pre-programmed method, and then press play, and this will prep for him. I'll talk to you guys soon when I come talk about the trace clean and automated acid steam cleaning. Thank you for listening.
Thank you, Stephen. Our next speaker today, I'd like to introduce Eric Farrell. Eric is the product specialist for the digestion and clean chemistry lines at Milestone. Eric obtained his bachelor's degree in biochemistry from Union College in 2005 with a focus in inorganic chemistry. Prior to joining Milestone, he worked in the particle characterization field as a laboratory manager and in domestic and international sales, where he supported sales and applications across all product lines. Thank you, Eric. Please take it away.
Hello, everybody. Thank you for joining us on our e-workshop today. And Steve, thank you for your portion. My name is Eric Farrell. I'm the product specialist at Milestone for digestion. So today I'll be taking you through rotor-based microwave digestion as it pertains to workflow in your laboratory for processing samples. We're going to talk a little bit about vessel handling, sample filtering, and other things that you may need to overcome in your laboratory, and tips and techniques to help you maximize your workflow so you're most efficient in your laboratory. So the whole reason we're here and in having these discussions is because we want to take a solid or liquid sample and turn it into a fully dissolved liquid, which you can put onto your ICP OES or your ICP MS. There's various different ways to get there, and we're speaking about, during this workshop, the various aspects of this workflow, from acid purity to make sure you have the appropriate acids, reagent handling. You heard about EZ-fill. Today, in this section now, we're going to be talking about vessel handling, microwave digestion as it pertains to rotor-based systems, as well as filtration. So first, we'll talk a little bit about rotor-based technology. So rotor-based technology has been around for well over 30 years. It's established technology. The first microwaves back over 30 years ago were basically renditions of home microwaves, which were time and power. But over the years, we've really made a lot of safety features and enhancements to that type of platform to what you see here today. Going from time and power, we used to have measurements based on pressure, and then we have measurements based on temperature, which could either use an individual thermocouple in a reference vessel or a fiber optic cable. Now we've upgraded that to using sensors that live in the bottom of the microwave. This is how we control the temperature using EZ-Temp, which you'll learn about in a little bit. Basically, the concept of operation of a rotor-based system is you have individual reaction vessels that are processed in batches in a rotor or a carousel in a microwave oven type cavity, as you see here. This is our Maxi 24 HP, and I'm actually going to be using this today to digest some hemp flour that Steve had already prepared for me in EZ-fill. So I'm going to go ahead and show you how that digestion works, and we're going to go through the process of doing that. So closed vessel digestion has a lot of advantages over traditional open vessel or other techniques. It gives you higher digestion quality. Because the vessel is closed, you can work at higher temperatures and accommodate higher pressures. That allows you to reduce your digestion time from something that may have taken hours on a hot plate. You can do it typically in an hour or less in a closed vessel. It allows for faster digestion of multiple samples at the same time, because in a rotor or carousel, as you see here, we have multiple positions. With my Maxi 24 HP, I can run as little as a single sample up to 24 at a time. So for a cannabis laboratory, that means a batch of various cannabis samples in a run. Also, because the vessels are close to the environment, that allows us to reach lower detection limits. Open to the environment, you can have environmental contamination. You can also have less acid usage, because on a hot plate, you may have to add acid over time. But typically with a closed vessel, we can go from anywhere from 5 to 10 mils, which is typically used in a rotor-based system. Also, because the samples are close to the environment, you also have no sample cross-contamination. So our version of a rotor-based microwave system is the EthosUp, which you see behind me over here. The way that a rotor-based system works, you have individual reaction vessels that are processed in batches. And the EthosUp is a highly flexible platform. It has a large cavity, 17.5 liters. And the purpose of the large cavity is to allow us to accommodate up to 3 different types of rotors. It's a highly flexible platform. You can use one rotor, and then if your instrument's configured for it, you can simply swap it out for one of the other ones. For example, we have 3 different rotors. We have our Maxi 44, which is a high throughput medium pressure rotor for easier applications. We have our Maxi 24 HP, more ideal for cannabis, food, feed, and pharma. And then we also have our SK15, which is our high pressure rotor. That's going to be for more difficult type samples to digest. These are all controlled via EasyTemp contactless temperature control, which is in the bottom of the microwave. And again, in a few slides, I'm going to go over what EasyTemp is and the advantages of it to help you in your laboratory as far as achieving complete digestions in a safe manner with full control of the temperature. Now, there's a few things, challenges that you can run into when you're working with a rotor-based system. There may be the need to rerun a sample. Why would you have to do that? Most likely because you had an incomplete digestion. Maybe you had an exothermic reaction occur where it stopped the run, or you introduced some contamination, or contamination happened to appear in your blank. Steve did a very good job at talking about sources of contamination. They pretty much come from anywhere. So what's important here is you want to make sure that you as the operator, as the lab technician, you're doing everything you can to make sure you're not introducing any contamination. Sodium, potassium come from everywhere, but you have other contaminants that can come from other places. Simply just by handling your samples or any of the tools such as spatulas that are used to weigh out your samples. If you're working in a dry environment, you may be prone to static issues where your samples like kind of jump out the top a little bit. We have some solutions on and ideas on what you can do to alleviate issues working with static prone samples. I'm going to be working with one today. I'm going to be digesting 0.5 gram of some hemp flour, and you'll see how that'll work with this system. Also, with rotor-based systems, you do have to assemble and disassemble the vessels. At Milestone, we've tried to make it as simple as possible, but there is still some labor that is required where you have to take your vessel, you have to put your cap on it, and then you have to hand tighten down. This can take a lot of time, especially if you have 24 or 44 vessels. So we're going to go through a way to further optimize this, this step in your workflow. A vessel cleaning, once you do a digestion, you have to clean your vessel so you don't have any crossover contamination. We'll go over some techniques for that. Also, it might be on occasion that you have to filter your sample. For example, you're working with EPA 3051 for soil, sediments, and sludges, and that's just a leach for elements of interest using nitric or reverse aqua regia. You're left with the sand left over. So we have a good solution for helping you to speed up the filtration process if you're looking to filter your samples, as opposed to doing something gravimetrically that could take a long time. And then lastly, as you're doing your digestions, especially with nitric acid, you may start to get some NOx contamination inside your vessels. The NOx contamination can cause various issues, and you will learn what those are and how to alleviate them. So there can be various barriers to achieving a complete digestion. One of them is making sure that the sample mass that you're using is appropriate for your rotor. So if your sample mass is too high for your rotor, for example, you're trying to digest 0.5 gram of an oil in a high throughput medium pressure rotor, such as your Maxi 44, that can cause an issue because that will lead to excessive venting. If you're venting excessively, you can't reach your temperature, and that's because you can't accommodate the pressures that are generated from the decomposition of the sample. It's possible that maybe a sample was misweighed. So instead of having 0.4 grams, you have one that's 0.5 or 0.6. And if your masses are very different, that can cause some issues with incomplete digestions in some positions. Because with rotor-based systems, we run on samples of similar reactivities, which includes similar sample masses and acid chemistries. Maybe the digestion temperature was not hot enough. For example, you're trying to digest something in a Maxi 44 that can only go to 200 C, but you need to go to 230, and you can't do that on that type of rotor. So choosing the type of rotor on the next slide you'll see is very pivotal to making sure that you don't have any challenges that you stumble upon as you're working throughout the day with your samples. Some signs of incomplete digestions that you can get will include yellow sample due to residual carbon content. That's going to basically look like you took a yellow highlighter and soaked it in water when you dilute it up to final volume. Residual carbon content can cause polyatomic interferences on your ICP-MS. It can build up on your cone, your interface cone. Also, you'll notice that the sample may not only be yellow, but cloudy and have white chunky material floating. That's typically undigested organic matter. If you're digesting inorganic samples, you may have some unexplained sediment. So the rotor is the heart of the microwave. This is where all the magic happens. So you always want to make sure that you want to approach choosing the appropriate rotor when you're going to configure your microwave, that you have a rotor that can meet your throughput requirements, and most importantly also, make sure that it can achieve those complete digestions of your samples. So for example, a Maxi 44 high throughput medium pressure rotor, we have our operating temperature at 200 C, and that accommodates up to 35 bar pressure. Now you'll see I have specification temperature for all of them is 300 Celsius. That's how much temperature that's going to be the specification for most rotor-based systems, how much temperature they can withstand for short time periods. But the operating temperature is something we like to be transparent with, so you know for a Maxi 44, you can go up to 200 C, for the Maxi 24, 220 C, and the SK15, 240 C. Maxi 44 is going to be great if you're working with environmental matrices such as EPA 3015 or 3051. In fact, it was actually developed for that application. The Maxi 24 HP is more or less the Maxi 44 on steroids. It's the only rotor out there that can go up to 220 C and accommodate up to 60 bar pressure. This is uniquely useful because it provides higher throughput than our SK15 and provides higher sample mass capacity than our Maxi 44. So for example, those laboratories that may need to digest half a gram of cannabis sample or half a gram of a food feed type material, animal feed, you can do up to half a gram of that in this rotor. The SK15 is our high pressure rotor. This is going to be for those applications where you're doing polymers, metal alloys, ceramics, petrochem, and organics. But also what's important to note is everything you do in the Maxi 44 or the 24 can also be done in the SK15. Now, when we're working with closed vessels, we have to have a safe manner in which to ventilate any excessive gases in the case of an overpressurization. This here is our SK15. It's easiest to illustrate with this vessel. So what happens is we tighten this down with a torque wrench to 10 Newton meters. And then what happens is once you reach that torque setting, that's where the venting and reseal kicks in. So if during a digestion process you happen to exceed that 100 bar, this spring on the top is going to compress ever so slightly. It's going to let out your reaction gases, CO2 and NOx, and close right back up. At Milestone, we don't see ventilation, venting of your vessels as a mode of operation, but it's rather a necessary safety mechanism, something that we have to accommodate for. We don't want your vessels to vent constantly because that can cause issues such as loss of volatile elements, loss of sample even, and excessive venting can also pose safety risks because you're ventilating a lot of reaction gases, maybe even acid vapors. So the technology that all three of our rotors use to control the temperature is something called EasyTemp. What EasyTemp does is we monitor the temperature of every vessel, and we control off of the hottest, which we do for safety reasons. So this is an example of our SK15 being run on our Ethos Up. So you can see with simple color coding what the approximate temperature of your sample is. So if it's green, you're within 10% of your set temperature. If it's blue, it's a bit cooler. That may be a less reactive sample or a digestion blank. And if it's red, it's going to be a bit hotter. And for example, you can click on an individual vessel here. Sample number 5, I can see is at 211 degrees Celsius. So essentially, instead of having an individual reaction vessel that is your reference by using a thermocouple or a fiber optic cable, every sample is the reference. As they pass over the contactless sensor, whichever one is the hottest, that is the one from which we are controlling the temperature. Here's an illustration of how it works. So this is actually an in situ temperature monitor. We're not monitoring the temperature on the surface of the vessel, but we're actually monitoring the temperature on the inside of the vessel. So for example, if my sample is down here, this is where my contactless sensor is focused. The polymer material, which makes up a rotor, is all invisible to that. So you don't have to worry about your IR reading the surface because it is actually reading the temperature on the inside, which gives you the ease of use of a contactless temperature sensor, but the security and safety and accuracy of an in situ monitor. Now, one of the other issues that can cause a problem in your workflow as far as digesting a sample is if you have an exothermic reaction. You want to make sure that if you're working with samples that are prone to exothermic reactions, that your microwave hardware is able to safely accommodate that so you don't have an issue where you have to stop and rerun your samples. So in this case, we digested 0.5 gram of infant formula, which is high in fat and protein, so it's reactive, with 5 mils of nitric acid. It's a 25-minute ramp to 210 with a 10-minute hold. As you can see over here, sample number 2 turned red, and that is where this exothermic reaction is occurring. The way EasyTemp works is as it's monitoring the temperature, if it starts to see the sample is starting to increase in temperature too much of your hottest, it's going to temporarily pause the microwave output, as you see here. That's going to drop down your microwave energy temporarily while air passes across the rotors, coming in here, out the back. That's going to cool off your samples. And then once it comes back down to where it's supposed to be in your temperature ramp, it's going to continue with the rest of the run. The system uses something called a PID controller, which is essentially a feedback loop. So kind of like the cruise control in your car. So you set 25 minutes to 210, and the system's going to automatically adjust the microwave energy, as you can see the black line at the bottom, to make sure that we follow this pre-programmed method. All right, so now we went over some of the hardware things. Now let's go into some of the things in your sample prep workflow that can cause a bit of a bottleneck or a hiccup, things that we want to try and avoid. So first is going to be static prone samples, especially problematic if you live in an area that's very cold and dry in the winter, like up north somewhere, or even in the Midwest. What happens is if your samples are prone to static and it's dry, you have low humidity, your sample can pretty much try and jump out of the vessel. If you've ever worked with these before, you can understand the headache that this causes. So take a look here. This is an example of us trying to weigh out some hemp flour. You can see it kind of jumping off the spatula, and it's even, you have a little bit that's on the sides over here, right? So there are a few things that you can do to alleviate this. This is really going to happen. The reason it happens is because all of your vessels with which we are working are polymer based, so they are prone to static. One of the things you can do is you can take this, and what I suggest is rinse the inside with DI water. You don't have to dry it completely, just dump out whatever water is in there, and then gently you can use a damp Kim wipe to wipe the outside. Another thing I will do on occasion is I'll tap this to a ground, such as the faucet from in my laboratory. There's other things you can do as well. There's ionic fans that are available. Milestone does offer one, but there are ones that are out there as well. If you have these issues and you're interested in the fan, we can help you with that. There's also anti-static bars. At my last job, I used to use anti-static bars inside my balance of my analytical balance because I was weighing to 4 decimal places quite often. Those work quite well. And then you have an anti-static gun. That's another option. So you do have different options depending on what it is, what type of sample you're working with, and as far as different solutions for combating a static issue. So right now, I'm going to go ahead and weigh my sample. I've already rinsed this out with DI water, so I know I don't have any static issues. So this is what it's going to be like when you're weighing out a sample with your Maxi 24. So my Maxi 24 vessel can go directly onto my balance. I'm going to go ahead and put on some gloves here. So the vessel itself weighs about 156 grams. This is a 220 gram balance. So you can weigh them directly onto the balance as you do here. By weighing your samples directly onto the balance is going to be helpful, especially to help you prevent any contamination, because the more steps you have in your sample prep process, the more chances there are of contamination being introduced. So I have some hemp flour here. I'm going to go ahead and weigh out some hemp flour. I'm going to do about 0.5 grams of sample. Goes right into the top. I don't have any static issues here. Weigh that right in. Perfect. So then I get 0.5 gram of my sample. And then what I'll do is I'm going to take this and we're going to fill this with acid. However, my colleague Steve has already filled 2 vessels for me. Thank you, Steve. In our easy fill system for the AOAC method. So he's already filled 9 mils of nitric acid and 1 mil of hydrochloric acid. So I'm going to go ahead and take these vessels out. What's nice about this too is I had done my digestive. We had added the samples much earlier when Steve was doing it. But what's nice is you can let this sit. So even if you need to do a pre-digestion with your easy fill system, because the system is completely ventilated, you can let your sample sit in here and pre-digest. It's an easier way to do it if you want to do it that way. So I'm going to go ahead and take one of my samples out. And then what I'm going to do is cap it. The standard way of capping samples is, or capping your vessels, is you take your stopper, you put that on top, then you take your top piece and you hand tighten it like this. So imagine doing this for 44, 24 samples. It can be a lot. And then you give it a little twist there. So that can cause some issues in your workflow as far as it's tedious and inconvenient. First of all, nobody likes the manual tedious steps of having to do that. But also what happens is you may be working with people over time. You're filling multiple vessels. If you don't tighten them all the same way, that can cause inhomogeneous digestions, because if they're not tightened the same way, then you're not going to have them venting at the same temperature. So it kind of takes the human factor out of that. So one of the benefits that we have and one of the systems that we offer is something called our EasyCap system. What our EasyCap system does is it helps to automate the process of capping your vessels. So what I'm going to show you exactly how it works. It's right here. It's very simple solution. I place my cap right on top. Now I just turn it just a little bit to catch the threads. I go into here. I flip this to close. My power button's on over here. This works off of 110 or 230. Either one is fine. Then I go ahead and tighten it. And then once I feel resistance, I know my vessel's closed. Then I'll come over to here, grab my other sample that's been pre-digesting. Now I'm going to do the same thing over here. I'm going to assemble my cap, my cover. Just start it with the threads just a little bit. Put it onto here. Press the button. And then once it's tight, it's going to twist in your hand. And then you know that you're done. That's all you have to do for the EasyCap. Makes it much easier. And then also you can use the EasyCap on the back end, because once you're done with your digestions, you're going to need to depressurize each individual reaction vessel. So I can put this under the fume hood, depressurize it, then I flip my switch to open, put it in here, and then I can go ahead and take the top off. This is not stored under a fume hood right now, but you can certainly put it under a fume hood. It will work there, no problem. Okay, so what are some of the benefits that EasyFill is going to be able to provide you? First benefit is going to be higher productivity, because it's one less step that your laboratory technician has to do. It's going to help you open and close your vessels faster, improving your overall workflow. It's going to give you better digestion reliability, because all of your samples are closed the same regardless of operator. So by automating that process like you automate reagent addition with EasyFill, that's going to help to eliminate any human error. It's compact and affordable. You can put it under a fume hood. Mine isn't for today. And this is compatible with both our Maxi 24 HP and our Maxi 44 rotors. Okay. So before we go into this next step of cleaning vessels, I'm going to go ahead and show you the microwave program. So I'm going to go ahead, open up, and I'm going to take my rotor out. Now I'm going to go ahead and digest these two samples. So what I'm going to do here is, one thing that's nice about the Ethos Up chassis is it's a large cavity, but with the large cavity, it allows you to use the rotor in a manner like this. So you don't have to take the whole rotor out or put the whole rotor back in every time, especially if you're working with EPA 3015, which is 50 mils of water. That's 50 grams times 44. That weighs a lot. So especially if you have lab technicians that don't really have that upper body strength, it's a little tall, you are able to keep the rotor body inside. Just kind of rock it forward as I've done here. I'm going to put, before I do this, I'm actually going to walk over to my sample prep area here and give a quick vortex to my samples, because you always want to vortex them before you use them. So simple, just like this. Make sure your samples are all wetted. This will help you ensure you get a complete digestion. I'm going to put position number 1 and position number 13. I stagger them either side. There's no specific manner in which you have to balance the rotor. You're fine just like this. So I'm going to go ahead and put this in here. Perfect. Now I'm going to switch over my terminal to my document camera, and I'm going to show you how we go ahead and run a digestion using the cannabis method. All right, let's line this up nicely here. So first place you're going to start is you're going to go to your library book in the top right. You're going to go to, you're going to go to digestion, select cannabis, and then you have your various methods that are pre-stored in here. I'm actually using an AOAC cannabis method that you can see up top. So I'm going to go ahead and press OK there. And then in here, it's going to show you suggested sample masses and acids. And then over here, it's going to show you your microwave program. 20-minute ramp to 210 with a 15-minute hold, 20 minutes for cooling. Then I go ahead and hit save. I'm going to go over here. I'm going to tell it where I have vessels. It's not necessary, but it makes it a bit easier for tracking them. So I have 1 and 13. Then all I do is press the start button, say yes, hit play, and it's going to go ahead and do my digestion. So the backlit logo turned from white to red. So as you're working around in your lab, you get an idea of where you are in the digestion process. Red is digesting, white is ready to start. Once it's all done with my microwave program, it's going to start cooling. Once it's done cooling, it's going to take about 20 minutes. This will be flashing green. That means all completed. So then you can see from across the lab, I can go ahead and take my samples out. My office is actually right over there, and I'm doing many digestions most days. I can look right over it and see what the status of this is here. Okay? So while that's going, I'm going to let that go ahead and do its digestion. We're going to jump back over to cleaning vessels over here. So for cleaning vessels, you need to clean your vessels whenever you do a digestion, because at the end of the digestion, there's going to be some leftover contamination that might be in there. So you want to make sure that you clean them so you don't have any crossover contamination. You can do this with a simple rinse with DI water. This is good if your analytes are not in the percent level. You can do a closed vessel acid reflux, which is essentially going to be taking your vessel, adding maybe 5 or 10 mils of nitric acid, going into your pre-stored program. For Milestone, you would select cleaning and select the cleaning method, and then go ahead and run that. The other options we have are for deeper cleaning. Deeper cleaning can be in a heated acid bath or an acid soak, as well as our trace clean acid steam cleaning system, which you're going to learn more a little bit about, which completely automates the process for cleaning your vessels. So now we get to sample filtration. So sample filtration may be necessary on occasion. For example, you're digesting EPA 3051. That's going to be a leach for elements of interest. Or you may have some silicates that you're working with, or insoluble species you may have, such as from your digesting inorganic samples. You may have some calcium fluoride or something that's left over. So on occasion, you do need to filter your sample. The solution that we have for that is something called the SFS24. This is going to be great for acid digestion and solvent extraction as well. Challenges with sample filtration: takes a lot of time, it takes up a lot of space, and you have to clean up when you're done. If it's done gravimetrically, that's just going to take a lot longer to settle out. I did a digestion, for example, the other day on an ink toner, and I had some silicates that were still floating. If I was able to filter the sample, I would pull that out much faster because they were floating in solution. So I had to let it sit on the lab bench for a few hours. So the SFS24 has up to 24 positions. It provides faster filtration because it's under a vacuum. We have several types of filters available. You'll see what those are, and several different polypropylene racks that fit different evaporation flasks. In this case, we're going to be using 50 mil volumetric flasks, so you can QS 50 pretty easily. This is what it looks like in action. So let's take this, for example, we digested EPA 3051 using some soils. So you take your sample, you pour it directly into the system as it's under vacuum, and what that's going to do is it's going to draw the liquid out, keep your solids in the filter, and it's going to put your liquid down below in your 50 mil volumetric flask there. Once it pulls that all through, then you can go ahead and take it out. So it's going to be much easier than having to do this manually. Some of the main advantages of the SFS24: it's going to give you faster filtration, process up to 24 samples. You can use it for extraction and digestion. It's easy to use. The rack rotates for easy handling. It uses minimal fume hood space. You can use standard evaporation vials. We have different disposable filters that are available. These are the examples of the filters. So if you're using digestion, if you're doing digestion, you're going to be using maybe a ceramic filter. For organics, you may use a 1 micron, 0.2 or 0.45 glass or PTFE filter on that side. And one of the last things I want to talk about is removal of NOx contamination from vessels. So this is another thing that can throw a monkey wrench into your lab workflow, where what happens is over time is as you're working with your vessels, if they start to absorb NOx gas, they will start to absorb microwave energy themselves. PTFE, TFM, PFA vessels all absorb microwave, they all absorb microwave energy if they are impregnated with NOx gas. Typically, they're supposed to be invisible to microwave energy. If they are contaminated with NOx, this can cause premature vessel venting and incomplete digestions. So what we do is at Milestone, what we suggest is you do an absorbance test. You place your vessel right into the microwave, and then you run it for a fixed amount of time for fixed power. For example, for Milestone, 600 watts, 45 seconds. You take the vessels out and hold them. If the vessels are contaminated with NOx, they're going to be hot to the touch. Then what you would do is you would, if they are hot or warm to the touch, you bake them out in an electrical oven to remove any NOx gases. You want to bake them out in an electrical oven that does have ventilation if possible. This is going to be done for Milestone 160 degrees Celsius for 6 hours, preferably overnight. If you're not a Milestone user, refer to your manufacturer's user manual of your rotor and your microwave. So that's pretty much what I have for the sample prep workflow here. There's a lot of different steps that we're covering in today's workshop. We have the ultra pure acid as far as their duo pure reagent handling. You saw that. We went over vessel handling, how you can make that easier with our easy fill system. For microwave digestion, we touched on rotor-based systems. My colleague Gianpaolo next is going to talk about SRC technology, the UltraWave 3, which is actually behind me over here. He's going to be speaking about that. We have the ability to filter samples if needed, and then vessel cleaning, which you're going to learn a little bit more shortly. So with that, thank you very much for your time. I'm going to pass it back over.
All right. Great. Thank you for that presentation, Eric. Our next speaker for today, I'd like to introduce Gianpaolo Rota. Gianpaolo has been an application chemist at Milestone for over 15 years. Thanks to continuous collaboration with laboratories and universities located all over the world, he has gained substantial expertise in sample preparation for elemental analysis, with a focus on microwave-based instrumentation. In the course of his work, Gianpaolo develops new application methods, participates in international conferences, organizes training courses, and provides ready support to analytical laboratories. Thank you, Gianpaolo, for joining us today. Please take it away.
Hi, everyone, and welcome in this part of the symposium where we will focus our attention on the single reaction chamber microwave digestion. We have seen in the previous presentations which are the main challenges related to the workflow for the microwave digestion. Mainly are related to the obtaining the complete digestion of the samples in order to reduce the interferences during the analysis. You have the full recovery of all the target analytes, and of course, having a unit, a system that allow to avoid the reprocessing of the sample of the digestion. So basically, to fully digest your sample in one single run. Then, of course, another important challenge related to the workflow is to keep the level of the blank as much lower as possible. And this, it is related mainly to the amount of the acid that you normally use. So it's important to minimize the consumption of acids. And then last but not least, is of course the productivity. The workflow has an impact. This is one of the impact you have on the workflow, has a big impact on the productivity. And of course, it is important to have all steps that and the flow of the all steps that allow to keep a high productivity in your laboratory, especially if you deal with a lot of samples per day. So after this overview of the challenges of the workflow, we have seen in the previous presentation by Eric, how the microwave rotor-based technologies can improve some aspects related to the workflow. And then you can reduce these features that have an impact on the workflow in a very good way. And the technology, basically, as you have seen, is made by three important aspects. So there is a microwave cavity that usually is a large cavity, and it works in combination with rotors that has sealed digestion vessels that works independently. And we have a sensor. In all cases nowadays, it's a temperature sensor that measure the temperature and that control the digestion reaction. This type of technology, as you have seen in the previous presentation, takes a lot of benefits and advantages, especially if we compare this technology to the more classical way of the digestion, like hot plates or eating blocks. This type of the microwaves and the closed vessel digestion improve the environmental lab, the workflow, especially has a less impact on the workflow and improve the productivity, because basically the systems are easy to use, and then you have a library of methods. It is possible to work to achieve a higher quality of the final digestion solutions. However, these type of technologies present some limitations. So there are some limitations that are related to the technologies, because nowadays, as you have seen in the Eric presentation, the technology reached a very high level. We use this EasyTemp sensor that control the reaction. That is a very good way to have good overview of the digestion process. But this technology presents some important limitations related to especially the performance. So if you the performance really depends on the number of the vessels for digestion. So if you need to reach very high temperature conditions to digest your samples, you need anyway to work with a high pressure rotor that works with 15 samples per time. And if you have to increase the number, if you have a lot of samples per day, this anyway, of course, limits the productivity of your laboratory. Then there are some limiting related to the handling, especially for a high throughput rotor, where you have a lot of vessels, that needs to be closed and needs to be prepared. But anyway, thanks to some tools that we provide, it is possible to speed up this process. However, anyway, there is another way to really speed up that things, that is using the single reaction chamber, but later I'll give you more details about that. And then there is another limitation that is related to the stress of the components, especially of the vessels. When you work at high temperature conditions, the Teflon is constantly under stress of pressure and high temperature, and it is necessary to regularly replace that component. So, considering these limitations, Milestone several years ago introduced a new technology that in order to overcome all these limitations, and in order to really solve all that limits related to the rotor-based technology, we have to really move away from this technology to a completely different one. And I'm talking about basically it's not a microwave oven, but it's a microwave reactor. And then it is a small reactor, in 1 liter reactor, where the digestion is performed not in vessels, but in small test tubes. How the single reaction chamber works. Basically, as I said, it's a stainless steel reactor, but internally it's fully protected by Teflon, and the sample and the reagents are loaded into these small test tubes, and the test tubes are placed inside the rack. The rack are then introduced inside the cavity, inside the reactor, sorry. Then the reactor is closed and it is hermetically sealed by these clamps. After the closure of the reactor, the system automatically introduce some nitrogen gas in order to increase the internal pressure. Later, I explain you the details of that, but basically, this pressure it's to close the vials. It's used to close the vials. After the pressurization of the reactor, the microwave starts. The microwaves increase the internal temperature of the reactor, and we control the digestion temperature with a temperature sensor. We have during the digestion process, when we reach the digestion temperature, of course, we have the dissolutions of the sample. After the microwave program, the cooling starts. And the cooling with a single reaction chamber is made by water. There is a cooling jacket that surrounds the reactor and cool down the reactor. After the cooling, the system automatically removes the internal fumes made by nitrogen and residual fumes of the digestion. And then the reactor can be opened, and you can remove the rack and collect your final solutions for the dilution and then the analysis. So these are all the steps of the single reaction chamber technology. As you can see, the steps are a little bit different quite different comparing the rotor-based systems. But how this new technology, how this different technology can help to overcome the workflow challenges that we have seen before? Starting from the quality of the digestion, you have to know that the single reaction chamber, this technology allows to reach much higher temperature and pressure conditions than any kind of rotors with a rotor-based system. You can work really close to 300 degrees of temperature with a maximum pressure at 199 bar. And these, of course, these are superior temperature conditions allow to digest a lot of different kinds of samples, including stable and difficult matrices that normally are quite difficult to fully dissolve with a rotor-based system. And of course, thanks to these high temperature performances, it is very, you can avoid to have multiple digestion of the sample. So you digest your samples in one single run, and you don't need to rerun the digestion several times. So the superior temperature conditions basically give you the benefits to fully digest to all the samples in your laboratory, including the more stable matrices. And digesting your samples at higher temperature conditions allow to basically increase the quality of the final solutions. What does it mean? It means that when you digest your sample at very high temperature, basically the amount of carbon that's still present inside the solution decreases. And this is a very important factor because the carbon inside the solution could create some interferences during the analysis. And in order to avoid these polyatomic interferences created by the carbon molecules, it is important to reduce the amount of this element inside the final solutions and increasing the temperature, as you can see from this graph, where we have three different types of matrices. With the increasing of the temperature, the amount of the carbon inside the final solution decreases. And this basically helps in the final analysis because you have solutions that are much easier to analyze, and then of course these avoid any possible misunderstanding during the readings of the data and during the recalculation of your data after the analysis. Superior temperature and superior pressure. So 200 bar, close to 200 bar of pressure, 199 bar of pressure. It's a huge pressure that the system can handle. And this, it's important, of course, this allow us to reach very high temperature conditions, but the possibility to work with such a robust reactor allow us to increase also the sample amount. The sample amount, it's an important aspect that especially can help us to improve the detection of elements and the analysis, especially if we have a sample that is not well homogenized. And this technology allows to work with a larger sample amount in order to have a more representative amount of sample and to have more stability into the analysis. Of course, digestion of high temperatures, of a high sample amount helps also to detect elements that are present in a low amount. So to perform the detection of trace elements in low concentrations. So these aspects are very important, has improved the quality of the digestion, and have, of course, despite the workflow, and later we will see some aspects related to the productivity. These improve a lot the quality of the final solutions and make easier the analysis. Of course, having a unit that make solutions that are easier to analyze, speed up, of course, the process of the overall analytical workflow. Few words about racks and vials. As I said, the unit doesn't use closed hermetically closed vessels, but works with test tubes, with vials. The vials are available in different materials: Teflon, quartz, and disposable glass. And these vials, working with vials is much easier than working with any kind of vessels, because basically the handling is close to zero. You simply load your sample, you put the acid, and then you close the cap as you see in that picture. You have just to close it, like putting the cap on it. The caps are not hermetically closed because what the caps are closed by the pressurization of the reactor. And later I'll give you more details about that. So the handling is really close to zero here. You just put the cap on the vials and then put the vials inside the rack. There is another aspect that I want to underline, that is related to the cleaning. When you work, it is very important, of course, to perform some cleaning between, in order to avoid, the cross-contamination from one digestion to the other. And the Teflon material that we use, and especially also if you work with quartz vials, you really reduce the memory effect from one digestion and the others. Because especially, as I said, for quartz vials, the cleaning is much faster and easier, because quartz is much more rigid material and doesn't really absorb elements during the digestion. Of course, there is another great advantage, that is with the use of disposable glass vials. With disposable glass vials, you really avoid any cleaning, so you eliminate the step of the cleaning step, and this has an impact on the productivity, and it's something that you have to consider, especially if you work with a lot of samples per day. To have, this system, basically, you don't need to stop the production for the cleaning, because the disposable glass vials doesn't need any cleaning step. Working with vials, of course, allow us to reduce the amount of the acid volume, and it is really possible to minimize the volume of acid for your digestion, and this has a great impact on the level of the blends. Then the possibility to perform the digestion at very high temperature conditions, as we have seen before, allow us to perform the digestion using diluted acid. And less acid means less possible contaminants coming from the external environment, and this, of course, has a high impact on the quality of the blends that you obtain. And then, of course, this is something that only the single reaction chamber only the single reaction chamber allows this, because the performances that system can give are very, very, very high. The other great advantage working with that type of technology is that the unit is made, there is the stainless steel reactor, and inside the reactor, you will see later in the demo, there is a big Teflon vessel. In this Teflon vessel, we put the racks inside. And in this big Teflon vessel, there is some water that surround all the vials. The water basically helps to create an equilibrium of temperature between all the positions. So we measure the temperature not in one single vial, but we measure the temperature of the external water that surround the vials, And if you have an exothermic reaction in one position, this reaction creates an energy that is immediately absorbed by the water, and this water immediately distributes this energy in all other positions. And this is a very interesting thing because this type of homogenizations allow us to work with completely different type of samples in one single run. I mean, you can load different samples and different acid volume, different type of volumes in each positions, and anyway, the temperature is the same in all vials. The same is also for the pressure. Before I said that we pressurize the reactor before running the microwave program because the cap of the vial is not the Teflon cap that you see here. This cap is just to avoid any external contaminations from the environment of the lab or when you remove the rack from the reactor to avoid that some droplets on the cover jump into the vial. But the real cap of this vial is the nitrogen gas. So when we pressurize the reactor, the nitrogen is free can enter also the vial because the cap has a small hole. Now I cannot show you, I'm sorry, but there is a small opening and the pressure is able, the nitrogen is able to enter also the vial. So there is an equilibrium of pressure from the internal and external. There is an equilibrium of the internal and external pressure of the vial. And this is very important because basically the vial, the pressure inside increase the boiling point of the liquid, of the acid, and this avoid the cross contamination between all the positions. And this pressure avoid also the loss of volatile elements. Then, thanks to this communication of pressure from the internal vials and the external reactor, this helps to create an equilibrium. So if I have an exothermic reaction in one position, this increases the pressure inside the vials that also increase the pressure of the reactor and also increase the pressure of inside all the other positions. And thanks to this principle of equilibrium of temperature and pressure, basically we can perform the simultaneous digestion of any kind of samples with any kind of, with also different type of acids, acid volume, sample amount in one single run. So you can create one digestion method to perform the digestion of all these samples. And of course, this has a high impact on the workflow of the lab, especially related to the productivity. The other things is related to the efficiency of the heating and the cooling. The system is quite powerful in generating the microwaves, and the cooling is made by water. So there is a cooling jacket that surrounds the reactor, and this helps to shorten the time of the cooling. So instead of cooling, I mean, the cooling usually takes 12 to 14 minutes, considering a final digestion temperature of 280, 270 degrees, till the 80 degrees that usually is the temperature recommended to release the pressure and open the reactor. So it's very fast. And of course, shorter microwave programs have an impact on the productivity, of course. It is also very important to have this cooling also during the run in order to avoid the overheating of the external reactor and avoid the diffusion of acid vapors from the inside of the reactor through the Teflon vessel. All these aspects have an impact of the workflow and an impact, especially as I said before, on the productivity. Easy handling of the vials, especially if you work with disposable glass vials where you have not any cleaning steps. And then the faster heating and cooling program, the possibility to digest all different types of samples in one run, reduce a lot the time of the digestion. And if we compare rotor-based technologies with with the single reaction chamber system, we see a big difference where for each sample, the operator with a rotor-based unit takes more or less 110 seconds. Then with a single reaction chamber takes 64 seconds. And if we consider 5,000 samples, it means that with a rotor-based system, you can perform the digestion of all these samples in 19 days with a single reaction chamber in 10 days. And this means that the operator time is reduced of 40% with a single reaction chamber. So we have seen all the how this technology can really improve the workflow of your lab, because basically it has an impact on the quality of the digestion thanks to the high performance of temperature and pressures, and has also an impact on the productivity of your laboratory. And this it's a great tool that can really make the difference in your laboratory, and then really improve the overall workflow for the sample preparation. Having said that, the single reaction chamber is not so new technology, because we invented this type of technology in the 1998 with this big this unit, ultracave system, that however still available in our portfolio for some laboratories, but that we move from this unit to a more small unit, a unit with a smaller footprint, in order to match the needs of most of laboratories that have not much space in the lab. And we create the UltraWave 1. From the UltraWave 1, we move to the UltraWave 2, that basically we put some improvements in order to expand our applications, and basically we made a Rogers construction that allow us to really digest more different type of samples, more samples, including very difficult inorganic materials. And then we recently released the third generation of a single reaction chamber system, that is the UltraWave 3 that you see here. The UltraWave 3 allows to have bigger benefits, especially if it is compared with the previous generation of single reaction chamber that I have here, as you can see. And basically the first difference is related to the productivity. Thanks to the new racks, we redesigned the reactor in order to have more space and to introduce racks with more positions. And we improved the productivity with 30% more thanks to the new rack. Then we improved the handling, so we add some more things that speed up, that make the preparation of the vessel, of the vials, and the closure of the reactor much easier. And of course, we introduce new features to have a better control of the reactions inside, and we introduce a new components for the microwave generation. Concerning the productivity, we have available racks from 7 till 40 positions. The difference from one to the other, it's basically the dimension of the vial. So according to the sample amount that you have to digest, you can choose the 7 position, or the 20, or the 27, or the 40 positions. I mean, the only difference is the sample amount and not the performance. The performance is still the same. So you can work at very high temperature conditions with high pressure, but what changes is only the sample amount. And then you can reach anyway high temperature conditions, even if you work with 1-2 grams of sample with a 7 position rack. Of course, as I said, for most of the racks, Teflon, quartz, or disposable glass vials are available. The materials of vials change according to your needs. We completely redesigned the reactor. The reactor, comparing the previous version, is we make it more robust in order to have a unit that can really increase the lifetime of all components, and that is, you also can increase the safety for the operator. The unit is fully protected by Teflon. I mean, all the parts of the component, all the reactor, as I said before, it's fully protected by Teflon. And the construction of the pressure line is entirely made with a special alloy that is resistant to acid corrosion. This is an innovative, it's a good thing, especially because allow you to work with all type of acids without any limitations. You can work with hydrochloric, hydrofluoric, aqua regia at all temperatures. I perform digestions of precious metals at 280 degrees with aqua regia, with a long program, microwave program. And this is possible to perform it because the system is designed to do that. I mean, so the construction of the pressure line are made with this special alloy that is resistant to corrosion. And then, of course, you don't need any extra parts to work if you work with hydrochloric acid, for example. So the unit is ready to work with all kinds of acids and to work most of the digestion of most of the samples. The other important aspect is that the pressure line is separated. So we maintain a separated pressure line where we have one tube for the inlet of the gas, of the nitrogen gas, and a separate line for the removal of the internal pressure after the digestion program. This is very important in order to avoid that the condensation droplets, because when you remove the gas from the reactor, could be that some droplets, could be that happens the formations of some droplets in the outlet lines. And in order to avoid that these droplets go back into the reactor, we keep this separated. So it is not really possible to have that these droplets goes down inside the reactor with the risk to contaminate the solutions and to have cross contaminations, since we have this separation of the lines. And of course, anyway, after the digestion, the system anyway automatically flush the pressure lines in order to remove these droplets before the opening of the reactor. And this it's very important to minimize possible contaminations from the environment, and then helps to keep low blends and to prolong the lifetime of the tubes, of these two parts. The new things that we implemented also is the magnetron. Yeah, the magnetron on this unit is a new type of magnetron that works. It is cooled by water and not by air. The magnetron is a fundamental component, of course, of a microwave unit, and it's basically responsible to generate the microwaves. It is important that the magnetron stays at under ideal temperature conditions in order to have high efficiency of generation of the microwaves. Normally, the microwave systems cool down the magnetron by fan, so using air, and the Ultrawave 3 is the first unit that works with water-cooled magnetron. So we cool down the magnetron by water, and this cooling is much efficient than using air. And these allow us to have high efficiency of microwave generation, even if you work at extremely high temperature conditions. And of course, these reduce the stress on the high voltage components. And the other nice benefit that you have from this picture is that the unit is very, very silent. So while the system works, you don't listen a noise. I mean, the system when it works, the maximum noise you have is 32 decibel. That is very, very low. So the unit doesn't add extra noise into the lab. we also implemented a new way to control the reaction. And you have already seen this sensor with Eric presentations when he presented the Ethos system. And this is the EasyTemp, and it is a contactless sensor that measures the internal temperature. And it is an infrared sensor that is able to basically reads the frequencies that are transparent to the Teflon materials. And we have thanks to this sensor, we have a very accurate readings of the internal temperature of the reactor. The other important things is that on the previous generation of single reaction chamber, we use a thermocouple system. And moving from this new way of measuring the temperature, we are not measuring the temperature in one point of the reactor, but we are measuring a wide area of the reactor. And this helps to have a better control of the digestion process, and the unit is very precise in controlling especially the exothermic reactions if you digest reactive samples like petrochemical, polymers, and so on. Okay, so this is an overview of the microwave, of the single reaction chamber technology, and I hope this was good for you to at least see how this can really have a good impact on the workflow of the digest sample preparations workflow. Now it's time for a short demo where I show you all the steps for the digestion using the Ultrawave 3. So I got collected the samples that Steve already prepared for me, that I keep it under the fume hood, and then I back for the digestion. So here I have the samples that, so thank you, Steve, for this. So here we have a big variety of samples from polymers to cannabis oil, and then CBD oil, sorry, and then food materials and others. And I remind you that we are using a small amount of acid. This is just 5 ml of acids. And I'm going to perform the simultaneous digestion of all these samples using the unit. For to do that, of course, I have to prepare the base load, so to introduce the water inside the reactor. For that reason, I move the camera a little bit closer to the unit. Okay, so you can see from here. So this is the reactor, the stainless steel reactor, and here I have the software that I use to monitor and to control the system. So the first thing to do, as I said, is to introduce the base load. The base load is made by 120 ml of water plus 5 ml of nitric acid. Nitric acid is used only because, especially if you work at very high temperature conditions, helps to absorb the microwaves. Because water, when you work at high temperature conditions, absorb less microwaves, and nitric acid helps us to absorb microwave even if you are working at a high temperature, with high temperature microwave. So to do this operation, the first thing to do is to remove the Teflon vessel like that, and then I already prepared the base load here. Okay, I put the base load inside the reactor. This is a constantly ventilated environment, so I can leave, when I do this operation, I can put the rack here on the side, okay? When the base load is inside the vessel, I can introduce the sample. After that, I show you the software. Sorry, I moved the camera a little bit closer. Okay. And this is the touchscreen software that controls the unit. This is a tablet that you can swipe from one page to the other. And then here there are different icons that allow you to control the system. And these are all icons that allow you to create a new programs or to open a new program. There is a library inside that is divided in different fields. You can select the method that you need to perform, to run, according to the samples that you are digesting, that you want to digest. And in this area, there are icons related to the information on the system. So here you can find user manual, video tutorials, and many other informations related to the unit. And here there is under this line, there are all the recent files that I opened. So I have prepared this method that is mixed samples. I simply open it and then I press start. When I press start, the system closed. The system start to close. So let me move back the camera so you can see. And the software is driving me in all the steps to completely close the reactor. So, okay. See the cover, it's going down. And now there is one manual operation that basically means to close the clamps. So when the cover is completely closed, we have to manually close the clamps. I move the first clamps here, then I move the second one. And then I seal the reactor by tightening this screw. The closure of the clamps, it's very, very easy. You don't need to use any tools to close them, as you can see. And you just close it till the end of the screw, and that's all. Okay, when this is ready, we can start the program. When I press OK, the system, there is one safety pin that lock the clamps. So if you have pressure inside the unit, it's impossible to open the clamps or to close them. I don't know if you can listen this noise, but it's the pressure that is loading inside the reactor. I'll show you from the software. That is easier to see. Now the unit is loading the pressure up to 40 bar. And with this pressure, we are sealing the vials. When we reach 40 bar, the unit starts with the microwave program. The microwave program can be visualized directly from here, from this panel. And in this panel, you can see the values of the temperature. So the red line is the temperature. The blue line is the value of the internal pressure that you can even monitor from this part of the software. And the orange line is the external temperature of the reactor. This is a very important temperature that allows to have to protect the cavity to any possible overheating, especially from on the outside. And this minimize and reduce the possible the diffusion of the gas from the external base load to the internal cavity through the teflon and to the stainless steel. So this really helps to protect the stainless steel, especially if you work with aggressive acid media like hydrochloric acid, for example. The system is now working. You cannot see very well from the camera, but there is a LED here inside that change color according to the status of the unit. And this is important because the system is so silent that, it's difficult to understand if it's working or not. For that reason, we put this LED that changes the color, and so you can recognize if the system is working. Now the color it's red. That means that it's working and it's controlling the digestion is running. When it turns to blue color, it means that the digestion is completed and is running the cooling of the reactor. And when it's green, it means that the reactor is ready to be opened and you can take the vials for the final dilution. Concerning the vials, I just want to show you again the software. Now, as you can see, the black line are the microwave emitted by the system, and the red line is the temperature inside. As you notice, the system is very, very precise and accurate to measure the temperature, and this is very important in order to have a good dosing of the energy, especially when you work with petrochemicals or samples that are extremely reactive. While the system works, I can move in other pages. I can see one video tutorials. However, I have this sidebar that constantly allow the user to have a view of what is going on inside the reactor. So you can see the internal temperature, the external temperature, the pressure, and the microwave emitted by the system. Okay, as you can see, the touchscreen is very sensitive, even if I'm wearing the gloves, it works fine. And after the digestion, the result it's something like that. So you have transparent solutions and ready for the final dilutions, and then the analysis. To recognize the position of the rack, we supply this plate where there is one fixed position that is the position number 1. And then the position number 1 you can recognize by these two. There are 2 holes here that inform us that this is the position number 1. And then when I place it on the rack, the position number 1 lifts. So this helps the user to remove all the vials from the rack. Okay. So that's all for the single reaction chamber technology. I hope this was a good occasion for you to have an overview of the system and to understand all the major principle, all the major concept around that unit. So basically, we have seen how this unit can overcome all the limitations, especially to consider the whole workflow of the sample preparation. And the single reaction chamber is really something that can further increase the productivity of your laboratory. And this is very important, especially if you deal with a lot of samples per day. So thank you very much for your attention. And if you have any questions, we will answer during the question and answer section. Thank you.
Thank you so much, Giampaolo, for that informative presentation. And now we'd like to welcome back Stephen Marco, who has another presentation for the audience. And please take it away, Stephen.
Okay, so now that we've finished our microwave digestion and any required filtration, we're going to move on to our vessel cleaning. And to accommodate that, we're going to use our Milestone solution known as the TraceClean, and it's going to automatically clean our vessels using acid steam. There's a lot of traditional methods to cleaning your vessels and vials. Traditionally, acid leaching or acid bath is the most commonly used. A lot of downsides to this technique: high risk of exposure to acid fumes for the operator and really the lab and all the equipment around it. It can cause corrosion issues on equipment, just having that around, even if it's in a fume hood. So it's always best to avoid that from a safety standpoint as well. All the components that are sitting in that acid bath are simply sitting in dirty acid. So they're still exposed to the contamination that you're trying to get off of it. It does help, but it is not the most efficient method to clean these. You go through a lot of acid consumption. That acid gets dirty quickly. You can't have it sit in the acid that's overly dirty, so you do have to change it out frequently, so it's going to increase your acid disposal cost. The cleaning time is long. Generally, you have to soak for at least 24 hours, so it's a very inefficient process. Just touched on that costly waste disposal due to using high volumes of acid, and Really, it's going to limit your lab's productivity because you're going to take up half a fume hood with a big acid bath, and all of the components that you need to digest your samples in order to analyze your results for either commercial purposes or research purposes are just going to be sitting there unused while they're being cleaned. So we want to make this a more efficient process, speed it up. Another common methodology for cleaning is just cleaning the vessels in their microwave, whichever respective microwave you're using. It's effective, but it lacks efficiency. The really major downside here is that, again, instead of using your microwaves to digest samples for your research purposes or commercial purposes, quality control, whatever your daily workflow entails, having to use your microwaves to clean vessels that you need to get these sample results is going to introduce a bottleneck into your lab flow. Also, you're going to use those components in cleaning to run the microwave, but it's still a digestion. It's still going to impact the lifetime of the microwave components, all the high voltage components, as well as any consumables such as your PTFE vessels. So to solve for these problems that common traditional techniques utilize, we came up with the trace clean. How the system works is acids placed in a reservoir on the bottom of the system here. The components that you're trying to clean, anything acid resistant, you can do. In this case, I have all of the vessels loaded up from the previous presenters. I have 24 from our Maxi 24 position rotor and 20 from our UltraWave 3 digestion system. But the acid's placed in the reservoir. All the components are placed in the hollow rods. The acid is heating using a traditional hot plate on the bottom, which generates a clean acid vapor. These vapors pass through those hollow rods and reflux inside of the components that you're cleaning within the system. It refluxes around and all the contaminants drop back down into the acid reservoir, kind of similar to how the Duopure does with its distillation. We want to leave those contaminants behind and only clean what we're trying to clean. So all that dirty acid falls back in the reservoir, and within about 2 hours, the system is going to be done. You take out your components, give them a quick deionized water rinse, and they're ready to go back into the process, clean down to those ultra trace levels that you need in your workflow. A lot of advantages of the system that we've touched on already. They're really going to improve your workflow. Being able to take off cleaning from your microwave system and move it on to its own independent technique is going to be very advantageous to your throughput and the quality of your results. It's efficient because it's going to eliminate the need for all those time-consuming acid baths as well as microwave cleaning runs. It's automated and convenient, just like the Duopure. It's a set it and forget it system. You load your vessels in, close the carousel, press play, and in about 2 hours, you've got clean, ready-to-use equipment. Widely applicable, we touch on digestion vessels and vials, but again, it can be used for anything acid-resistant. Glassware, ICP, accessories such as torches and cones, really anything that you need to get down to those trace levels, you can run it through the trace clean as long as it is acid-resistant. We're just using nitric acid for the cleaning mechanism. And it's safe. The entire system's enclosed under exhaust or with a dedicated exhaust to your fume hood or house ventilation system. And that's going to remove any operator exposure to acid fumes, just like our Easy Fill. So we're going to take all that cleaning step offline. We're going to automate the process, and we're going to be safe while we're doing it. So using the trace clean versus a traditional acid bath, the cleaning process in the trace clean takes place in a sealed container. So all that environmental contamination I talked about during my previous time on screen, we're going to mitigate that by keeping a closed system. Nothing's going to be able to get in, nothing's going to be able to come out. All the critical surface of the clean components are cool and dry when the cleaning is complete. We do always recommend a DI rinse just in case there's any acid vestiges left over, but that's more of a safety precaution. The stuff does come out ready to use. This eliminates the need to soak and change the acid baths like we talked about earlier, so your disposal cost is going to go down. You're going to free up all that space that acid bath is taking up in your fume hood, and you're going to be able to improve your workflow throughout that area as well by keeping up a nice clean area that's safe to work in. The system itself does not directly require a fume hood, but it does require a ventilation source, but it does have a very small footprint on a benchtop mechanism. And to speak to the quality of the trace clean performance, the top graph is a couple of different elements of interest with steam cleaning through a TFM and acid leaching. And you can see across the board, we had nominally the same cleanliness between both techniques. On the bottom are concentrations in PPT, same elements of interest. This is steam cleaning quartz material and acid leaching quartz material. And you can see the acid leaching, similar to the top graph, zinc, sodium, things that are high in your environmental contaminants, the particulates that we talked about earlier. Those are present because that acid bath is open to the environment. All of the airflow that the fume hood is pulling in, assuming that this acid bath was in a fume hood, is going to leach those contaminants into the acid, which can then continually leach them back into the equipment that you're trying to clean. So much more efficient process from a workflow standpoint, but also slightly better just because we're avoiding that environmental contamination through a closed container. And this is in comparison to microwave cleaning. So the digestion was performed on a soil sample with those elemental concentrations you see there on the left. We want to minimize